Among all the industries, chemical industry plays a key role in the climate discussion, which produce substantial greenhouse gas emissions, representing more than 30% of the global greenhouse gas emissions. With situations like this, we expect to establish a novel catalysis method preserving the traditional catalytic effects, and is able to target multiple chemical reactions, increasing safety and reducing pollution. In our research, we apply electron field, magnetic field, and electromagnetic field as catalytic methods, testing their catalytic capacities at different intensities in order to figure out the most stable and effective windows of catalysis.
Electric field. Oriented external electric fields can reduce the activation energy of chemical reaction by electrostatic catalysis, and it also can improve the stability of intermediate products. Each molecular's bumping rate can be raised. It increases the frequency of other product bumping, and the valid bumping rate of molecules can be raised at the same time, so the chemical reaction rate increases. Magnetic field. First, the magnetic field can act on the basic constituent unit of the reactant material, nucleus and electron in a non-contact energy transfer rate, thus effectively increasing the rate and reaction path of its chemical reaction and other parameters. Second, for the mechanism of inorganic chemical reaction in aqueous solution, the magnetic field can make it vibrate. When the system is subjected to the action of the optimal frequency field, resonance can occur. Its energy can change the ionic bond and change the structural characteristics of the system. Under different electric or magnetic field, the mass transfer is strengthened and the reaction rate is increased.
We will take the reaction of sodium thiosulfate solution and dilute sulfuric acid as experimental objects. We set the reaction without any catalysis as the control group, and use the electric field, magnetic field, and electromagnetic fields to set up 3 experimental groups, and each of them was carried out at 4 different intensities. In order to reduce the experimental error, 7 experiments were performed separately in each intensities, and the experiment values were removed. Based on the figure, the catalytic capacity of electric field from voltage range of 5 volts to 35 volts, which first rises from -6.2% to 7.8%, and then decreases to about 0, which has the best capacity at the voltages of 15 volts. Therefore, the catalysis of electric field for this reaction is best at about voltages of 15 volts, and due to the small variation at higher voltages, it is assumed that the catalytic ability of electric field at higher voltage will not be significantly improved compared to the case having no catalysis. Based on the figure, the catalytic capacity of the magnetic field from the voltage range of 5 volts to 35 volts first drops sharply from 10.3% at the voltages of 5 volts to -1.5%. and rises to 11.8% at the voltages of 35 volts. So the optimal voltage for magnetic field catalysis is about 5 volts and 35 volts. Due to higher effective catalytic capacity of magnetic field at the voltages of 35 volts, it is inferred that magnetic field at higher voltage may have a more dramatic effect. However, considering too high voltage is dangerous, this study will not discuss. Based on the figure, the catalytic capacity of electromagnetic field is roughly rising from the voltages of 5 volts to 35 volts, and regardless of the voltage, the catalytic effect is positive. Meanwhile, since the catalytic capacity is positively related to voltage, it can be inferred that the electromagnetic field has a relatively stable and good catalytic capacity, and the catalytic capacity will also increase with the increase of the voltage.